All right, so if you're scooted forward, put everything away, remove all distractions. So this is, here's what I'm trying to help you do. You know what camp you're in here. Some of you had pretty decent scores, but I just feel like you could have higher scores. In that case, some of you were borderline, maybe you had a C on this, but I think you would get below that. And it's, I kind of want to help you push yourself along to that track where your goal is a little higher than maybe what it is right now. Some of you, I'm just trying to help you get to the point where you're going to pass the class. This is for you. I really want to get you to a point where you understand this well enough to be functional with it, right? So why don't you close those up, click them all the way closed, have a look. We'll just talk through this. I think this is the best way to learn math, honestly, this is the prime day because you've worked on this stuff before. You know a lot of it, but you don't know it all. And so we're going to fill in some gaps. The things that in this, hopefully you'll come out of today saying, okay, man, I got this. Now I totally understand every little thing I didn't have. I now get. And I'm ready to go retake this thing. And I'd love it for everybody just got an A on this. That'd be great. And there's no reason it can't happen. I don't curve it or anything. If everyone gets a high score, everybody gets a high score, right? So here we go. First part is talking about selecting the best method for solving this, right? So this is where we just want to go through a few steps, and then we're just going to apply that criteria that we have, like that flow chart that we talked about earlier. So what's the easiest way to do this? Before we do anything, though, what do we have to do to this equation? Got to put it in standard form, right? We got to get it equal to 0. So I'll subtract 8 from both sides, and that gives me 4x squared minus 4x. What's that going to be? Plus 9 equals 0. Everybody agree? Okay, so this one now, can I divide both sides by anything here? Is it convenient to do that? Is there a number that divides into everything on all the terms on the left side?
No.
I can't really divide by 4, right? If I divide by 4, does everybody see the problem? That's going to give me an x squared there, which is good. It's going to give me a minus x there, but it's going to give me a 9/4, and I have a fraction. And I don't want to introduce fractions. That makes things harder, right?
Yeah.
So this is an easy one then. If all I'm trying to do is select the best method, if I'm stuck with a, right, the coefficient of x squared, because we put this into standard form. Which is just ax squared plus bx plus c equals 0. If a is not equal to 1, right away, which technique are we going to use for sure?
Quadratic formula.
Quadratic formula, right? We don't want to mess with doing any of the other ones because they're going to be hard. Factoring is going to be hard. Completing the square is going to be hard. All that stuff will be hard. I'd have to deal with fractions. I'd have to do a lot of work that we don't want to do. So we'll just throw this into the quadratic formula and we're done. We have to, at this point, we're not even doing it. We're just selecting the method. So this would be quadratic formula, right? That's it. Okay. Moving on. Questions on that? Once again, because we were unable to divide both sides by 4 and make that an x squared, it's a 4x squared. We're stuck with something times x squared, and we can't isolate x, which we can't do because I have multiple x's. We default to the quadratic formula. Okay? First step. Put in standard form. So I got to move everything over to the left side where I get a positive number of x squareds. Everything cancels over there. Well, that cancels too, right? So I end up with 5x squared minus 15x equals 0, okay? So this is, in my opinion, this is good news. This makes it easier if you only have 2 terms, because there's only 2 possibilities. There's only 2 terms. I'm not going to mess with the quadratic formula. I'm not going to complete the square. I'm not doing any of that stuff. I'm either going to isolate x, can I? No, I can't because I have x squareds and x's, so that's off the table. The only thing to do then is to factor, right? So what can I undistribute from both? 5x, right? I can undistribute a 5x. And what's left over if I do that? Well, I'm just going to divide each by 5x. to see. So 5x squared divided by 5x is what? X. And that works because 5x times x is 5x squared. 15x divided by 5x is what?
-3.
Good. Okay, so it factors. And a lot of people just left it like that, which would get some partial credit, but just didn't do that one last step. Well, actually, never mind. We're just trying to select the best method. What is it? Factor and apply the zero product property, right? I guess while we're at this one, let's just finish it. We're doing more than the question asked. But if I wanted to actually get the solutions, I would just set these equal to 0 and find out. So there's my factor number 1, factor number 2. If I set 5x equal to 0, what's the answer? 0. And we know that if I ever have a monomial out there, a greatest common factor with an x in it, it's always going to, when I set it equal to 0, I get the solution 0 every time. What about this one? So if this were on part 2 of the test, in Moodle, we just would have entered 0, 3. It's not, it's on part 1. And so the answer is factor, and then use the zero product property, right? That's what we want. Okay? Because we have two terms and I can't isolate x. What about this guy? Standard form. So a couple ways we can do that. Let's just add 6 to both sides first. And that gives me negative x squared minus 4x minus 10 equals 0. What's the last thing I need to do?
Positive.
Make them positive. Multiply both sides by -1 so that that's positive, that's positive, that's positive. Yes, ma'am?
If you need to make A negative, but like, or A positive and like B or C are negative, or positive already, if you still flip it, is that still alright? Or do they all need to be switched to the same side?
No, everything switches. So in this case, the reason they're all positive is because they were all negative to begin with. If that had been positive to start with, it would have become negative.
Oh, so it doesn't matter, just to get the A?
Just to get A positive, yeah. Whatever, the rest we'll just take whatever we get, right? Okay, so then what are the things we're going to try? What's the first thing we're going to attempt here? Factor. Can we find magic numbers that multiply to 10 and add to 4? No, we can't, right? That's off the table. They don't exist. So factoring is out the window. What's next?
Complete square.
Complete the square. Should I?
Yeah.
Yeah, I should. Because A is equal to 1 and B is even. So then, if I can't find magic numbers, I just complete the square. Right? And we're done. Okay, that's that one. How about this guy? Pretty obvious what I'm doing here. Isolate x. I isolate x because there's a single x that I can point to. So I isolate x. That's it. What do I do here first? Standard form, so I'll subtract 4x from both sides. So I get x squared minus 4x plus 3 equals 0. Okay? What do I try first? Try to find magic numbers so I can factor. So can I find magic numbers that multiply to 3 and add to -4? I can't. What are they, Walker? You're right. Well, -3 and -1, right? Yep. So this one would factor into x minus 3 and x minus 1. So our answer is factor and use the zero product property, right? Okay. What about this guy? Pretty obvious. Isolate x, right? When I isolate x, I don't have to really do anything to see that. There's an x that I can isolate. There's only one x in the whole thing. So I'm going to isolate x. Good. Okay, so now we're on to actually solving these things, right? So let's go through just a couple examples of solving quadratic equations. I've thrown in just a couple of every kind. So let's look at these. Put it in standard form, you've already told me that, so I'm gonna add 2x to both sides, and I'm gonna get x squared plus 8x plus 18 equals 0. So first let's pick a method. Let's see, can I find numbers that multiply to 18 and add to 8? Seems like we could, but we actually can't we? Nothing works. Okay? So I'm not going to factor. What would I probably do? Complete the square. Because I've got a is equal to 1, b is even, right? So we'll complete the square. X squared plus 8x space equals negative 18. And then we're just going to add numbers to both sides to make this thing factor. So what's the number? We can maybe skip some steps with this now. What's the number that we're going to add there? 16 is correct. How come?
Divide by 2.
Okay, good. Because half of 8 is 4. Squared is 16. Good. Okay, so this tells us because 8 over 2 equals 4, we're adding 16 to both sides, which means on the right side we're going to end up with a negative 2, right? On the left side, what's that going to factor into? Well, what are my magic numbers that multiply to 16 and add to 8? 4 and 4. So x plus 4 squared. X plus 4 times x plus 4. Now we completed the square. What are the last two steps? Square root. Good. So if we square root both sides, I'm going to get x plus 4 equals, can't forget my plus or minus. What's the square root of negative 2? I'm going to get an I from the negative part, right? And then I'm stuck with a square root of 2 that I can't do anything with, right? Can't simplify that. No couples. If I break 2 into a factor tree, it's prime. So I end up with, on the right side, plus or minus the square root of 2. The negative becomes an I outside of the square root. Last step, subtract 4. So I get negative 4 plus or minus square root of 2 times I. Okay? Questions on that? Okay, no big deal. What else could I maybe have done on this that would have been almost as easy to solve? Quadratic formula. Can't factor, but we could have used a quadratic formula. If you really like that, that's fine. So I got to put this in standard form, right? We're going to subtract x squared. I'm going to add 4x. And I'm going to subtract 6. So everything cancels over here. On this side, I'm going to get 2x squared minus 6x. And look, the 6's cancel. So what am I going to do? Got two terms. I could divide by 2. That's fine. I could do that. If I want to make things a little bit easier, I could divide each side by 2. What's that give me on the left side if I divide both terms by 2?
Square minus 3x.
Now what? If I've got a 2-term polynomial where I've got x's in both, what do I have to do here? Pretty easy. I don't have to do anything fancy. Only one thing to do. We've talked about this for a while. I know you've done this. You always want to try this.
Isolate the root.
Well, okay, we could try it, can't I? Why can't I? There's an x squared and an x, so I can't do it. So if I can't do that, what's next? Factor. Yeah. I'm going to factor out an x. I just look for a greatest common factor. I can undistribute an x. What am I left with? Just x minus 3, right? Because x times what is x squared? X times what is 3x? 3, right? So I get x minus 3. And if all that's equal to 0, then my solutions are pretty easy, right? I'm just going to use the zero product property. I've got it factored. When I factor out a greatest common factor, that's a factor, right? So if I set these equal to 0, I get 0 or what? Okay, so in Moodle, I just go 0, 3. Okay? I would check that, of course, right? How can I check it? Plug them in, see if they work. Okay. How about this one? Isolated variable, no big deal. What do I do? 2 steps. Divide by -4. So that's going to give me -144. Now what? Square root. And that's going to give me x equals plus or minus, very good. And then square root of 144 is going to be 12, and the negative becomes an I, right? So my 2 answers would be 12i and -12i. Okay? What about this guy? Okay, what do I have to do first? Combine like terms, so standard form, add 2 x squared minus 15x minus 3 equals 0. Okay, so it's a trinomial. I got 3 terms. Can I find magic numbers? No, can't do it. Do I want to complete the square? No, how come? B's odd, good, not even, so we don't want to complete the square, so what's our only option? Quadratic formula. So remember that, right? Ax squared, if we start off in standard form, so ax squared plus bx plus c equals 0, the quadratic formula tells us x equals what? -b plus or minus divided by, and notice the division bar. I still see people doing this. The division bar is under everything, both terms, the -b and the square root, 2a. So what's that give us if we plug in here? What are my values of a, b, and c? A is 1, b is, c is, okay, so if we plug that stuff in, we get -b is 15, right? Opposite of -b. So 15 plus or minus the square root of b squared. What's -15 squared? Same as 15 squared. What is that? 225. Minus 4 times a times c. Well, what is that? 4 times 1 is 4 times -3 is, so I'm subtracting -12, and you added them up, I think, right? So we're subtracting -12 on the top. On the bottom, we get 2 times a is 2. So all we have to do is simplify that. Those are our answers, both of them. One's plus and one's minus. So let's break this up into 2 parts. Let's get rid of the common denominator. So we're getting 15 over 2 plus or minus. There's my plus or minus. Well, what's that work out to be? 225 plus 12 is 237. 237. Are we going to be able to simplify that radical? 237, it's probably prime. I can't think of anything that goes into 230. Well, actually, I guess 3 does, doesn't it? Maybe. We should see. So 237, let's try this. How do I know it's divisible by 3? If I add them together, 2 plus 3 is 5, plus 7 is 12, which is divisible by 3. So I know 3 goes into that. Let's see what happens. 3 goes into 23 7 times with 2 remainder, so 79. But 79 is prime. Nothing goes into 79. We can't find any factors of 79. So do we have any couples? Nope. So we're stuck with that under the radical. Makes it a little bit easier. So those are our 2 answers, right? That's it. Okay, so we end up, in Moodle, we would just put 15 halves plus the square root of 237 over 2, 15 halves minus square root of 237 over 2. Okay? And those look ugly, but all you're doing is plugging it in the quadratic formula to get those. What about this one? Isolate x, there's a single x. So what are the steps I would go through to get that x by itself? First I would what? So we're going to get negative 3x plus 3 squared equals negative 98. Now what? Square root both sides. So that's going to give us negative 3x plus 3 equals plus or minus. What's the square root of negative 98 going to be? Well, the negative is going to become what? I. And if I do my factor tree for 98, what would be a great way to break that one down?
714.
Could. That would work, but is there a better way? Can you think of one? Try to find a factor that's a perfect square. It's something squared. Like 25 is a perfect square. It's 5 squared.
Yeah.
49. That would work. 49 and 2, and 49 is a great choice because what is 49? So we get a couple of 7s and a single 2. Right? Couplets go out, singles stay in, and then we know that we've got this negative, which becomes an I. Right? And then the last couple steps. What do I do to get that x by itself? Subtract 3. So we're going to get a negative 3 there. And then last step, divide by negative 3. But remember, we've got to just be a little bit careful. When I divide the plus or minus term, do I divide it by a negative? That'd be redundant, right? We already have both plus and minus, so we just divide by 3. Okay, and our final answer then would be negative 3 over negative 3 is what? 1 plus or minus 7 radical 2 over 3, and I can't reduce 7 over 3. I'm done. Those are both my answers. Okay, question? Oh, and I, you're right. And the I, forgot the I. Okay, we'll put that outside the fraction. Okay? How about this one? Getting there. Buckle up. What's the one thing I got to do before I start? I know it sounds like a broken record here. We say this all the time, but I got to subtract 21 to set it all equal to 0. So I get 3x squared minus 3x minus, what's that going to be, 90? Anything else I can do to make that simpler? Divide by 3, good job. So then that's going to give me an x squared, what else? Minus x minus 90 over 3 is, can we find magic numbers this time? That multiply to negative 30 and add to negative 1. I mean, if you can't think of them, you just move on and use the quadratic formula. But if you can find them, they're easy. Where are they? Multiply to negative 30. So you can, and you might even just try doing this, and you can always just cross that step off. But what would the signs have to be if they multiply to a negative? One positive and one negative. Which one is bigger if they add to a negative? So maybe that helps. 6 and 5. And so what are my solutions going to be? Don't confuse the magic numbers with the solutions, though. Good, because we have to apply the zero product property. So x minus 6 is 0 when x equals 6. X plus 5 is 0 when x equals negative 5. So 6 comma negative 5. Okay? How about this? You can already kind of see what's going to happen here, can't you? If I subtract 6 to get it equal to 0, I get a 2x squared minus 14x plus 29. Can I divide by 2? Can't, because that's odd, right? So what do? quadratic formula. There you go. So we have our A, we have our B, and we have our C. So we just apply the quadratic formula. So x equals negative b, that's 14, right? Plus or minus the square root of b squared, 14 squared is 196, minus 4 times a, which is 2, times b, which is 29. All divided by 2 times a, 2 times 2 is 4, right? So what's this give us? 58 times 2 is 116. So we end up with 196 minus 116. I think I did that right. Yeah, I think I did. Gives us 80. So we get 14 over 4 plus or minus the square root of 80 over 4. What about 80? If we make a factor tree, what's 80 break up into? What do we do? I mean, just doesn't really matter. Just start somewhere. 5 and 16. Okay, we could do that. That's a good one. 5 and 16. And what's 16 break up into? Or better yet, 4 and 4. So I get a couple of 4s and a single 5. So this looks like, what's 14/4 reduced to? Good. 7 over 2 plus or minus. Square root of 80 becomes, right here we can see it's a couple of 4, single 5, so that's 4 radical 5 over 4. But 4 over 4 reduces to 1 over 1, right? And so our final answers are 7/2 plus or minus square root of 5. Okay, both of those. And last one. Subtract 28. So those cancel. 4x squared minus 24x, what, plus 40? What can I divide both sides by? 4, good. So if I divide by 4, I get my x squared, that's good. 24 over 4 is 6, 40 over 4 is 10. Can I find magic numbers that multiply to 10 and add to negative 6? Not going to work, is it? Well, only options are 1 and 10, or negative 1 and negative 10, negative 5, negative 2. Neither of them work. So what do? We could use quadratic formula. It was probably a little bit easier. Complete the square, because a is 1, b is even. So leave a space, negative 10. What am I going to add to both sides? 9, because half of negative 6 is negative 3, squared is 9, right? All right, if I square it, I get 9. So what's that mean? I'm going to add 9 to both sides. So we end up with a negative 1 on this side. What's that going to factor to here? What are my magic numbers that multiply to 9 and add to negative 6? Negative 3 and negative 3. Last two steps. Square root. What is the square root of negative 1? 1i, which is just I, right? So we get I on this side. Plus or minus, right? We got to do plus or minus. And then over here we get our x minus 3. Last step. Add 3. Those are our two answers, 3 plus I and 3 minus I. Okay? Just like that. Okay, we good? Okay. I had one other little thing, but that's too much talking. I'm done. So you can work on that. How many people want to be requested tomorrow to do a retake on this? Lots? Okay? Okay, I'll get you. It's possible I might have to get some of you on Friday, but one of the 2 days I'll get you for sure. Okay, you can work.